All right, so today we are talking about the distance formula. So let me get a working marker. Here we go. All right, so today we are talking about the distance formula. So the distance formula is going to help us find the distance between 2 points. And we could either use the distance formula or essentially we could use Pythagorean theorem, and I'll kind of show you both. But before we talk about the distance formula, so remember, if we have a coordinate plane, okay, we have an x-axis and a y-axis. This is clearly not drawn to scale. Okay, so as you can see, my x-axis goes from -3 to +3. My y-axis goes from 3 to -3. Okay, so say I had a point plotted on my graph. Okay, and I need to figure out the x and y coordinates. So remember, x comes first, y comes second. X tells you how far right or left you're going. Y tells you how far up or down you are going. So for this guy right here, I went over 2 and up 1, 2, 3. So the coordinate point is 2, 3. Okay, if I have this point, I went over to -3, and then I went up 1, so that guy is -3, +1. Okay, so for the point that I just drew, we went over 2, down 3, so it's 2, -3. Okay, hopefully that rings a bell because we will be needing to figure out coordinate points as we go through here. So our distance formula, D stands for distance, and then x2 x1 squared, y2 minus y1 squared. So your x's and your y's come from your coordinate points. Or to do this, we could also do a squared plus b squared equals c squared, the Pythagorean theorem, as long as we have a right angle that we are looking at. All right. Here we go. So just what I talked about. Let's plot some points. So remember, your coordinate planes are x and y. Your x moves left, which is going to be negative, or to the right, and that number will be positive. Y moves up, which is positive, or down, which is going to be negative. Okay, so if we were to plot these points, we'll start with 4, 3. So starting at 0, 0, that's always where you start. You're going over 4. 1, 2, 3, 4. Not plotting anything because we still got to go up 3. 1, 2, 3. And then plot your points right there. Okay? These little bubble marks, try not to write on your paper because it'll cause like a mess. I was just showing you, since you can't see, which direction I was moving. Okay, next one, -2, 4, starting at 0, 0, going left to -2 first, right here, and then going up 4, 1, 2, 3, 4, plotting my point at -2, 4. Next one, -3, -5, going to the left to -3, going down 5, 1, 2, 3, 4, 5, plotting my point. Then we got 1, -7, going to the right to 1, and then down 7. Okay. So hopefully that is just a review of knowledge and not new information. Okay, so now we're going to look at this graph to identify the points. So I'll start with this guy that I'm bubbling in over here. Okay, so we went over 1, 2, so x is 2, and then you went up 1, 2, 3, so y is 3. So 1 over 2, went up 3. Next, I'm going to do the guy in the upper left-hand corner. So it looks like I went over 1, 2, 3, 5. And then I went up 1, 2, 3, 4, 5. So that's -5, +5. bottom left, 1 over 2, down 1, 2, 3, 4, 5. So that one's positive, or negative 2, negative 5. And then last but not least, the bottom right, 1 over 2, down 1, 2, 3, 4, 5. So positive 2, negative 5. Okay. All right, so they want us to find the distance right here between A and B, and we're going to use this formula up here. So we need our coordinate points of A first. So let's take a look at A. It looks like we went over to negative 2 is your X, and then 1 up to 1, that's your Y. So I'm going to label this X1, Y1. B went over to 4 and then down to negative 3. Okay, I'm going to label those as X2, Y2. Okay, now we need our distance formula. D equals X squared, or X2 minus X1, all that is squared, plus Y2 minus Y1, all of that is squared. Okay, so I labeled my x's with x1 and x2, and then my y's with y1 and y2, so now I could substitute in my numbers. So I have x1 is negative 2, so I got negative 2 minus, oh sorry, I have them flipped, that was a mistake. X2 comes first, which is 4, so we got 4 minus x1 is negative 2. And all that's going to be squared, plus y2 is negative 3, y1 is 1, and all that's going to be squared. Okay, so we have in parentheses 4 minus negative 2, which gives me 6 squared, plus in parentheses over here we got negative 3 minus 1, which gives me negative 4 squared. Then I'm going to go ahead and square this. So 6 squared is 36. Negative 4 squared is negative 4 times negative 4. That gives you 16. Then we have, sorry, jumping ahead. We have 36 plus 16, which gives you 52. Okay, and it looks like this forgot the square root on the outside, so your last step is to take the square root. So second x squared 52, 7.21 is the distance between A and B. Okay, so if I were to draw a line like that, that's the distance. Okay, I'm also going to show you how to do this with the Pythagorean theorem, just so you could see where some of these numbers come from. So if we're going to use the Pythagorean theorem, that's a squared plus b squared equals c squared, right? Okay, so we know that the Pythagorean theorem works with right triangles. So that's what I'm going to do. I'm going to create a right triangle. I'm going to go up and then over to A, and then we're essentially trying to find out your diagonal, right? So we have A and we have B. So to find the length of A, we're just going to count the blocks. So 1, 2, 3, 4, 5, 6. And then count down 1, 2, 3, 4. So A is 6, B is 4. So if you notice, 6 and 4 are the same numbers that we get down here. Okay, so 6 squared is 36, 4 squared is 16, add them together, you get 52, take the square root, so the square root of 52 we already know is 7.21, so the diagonal here, C, is 7.21. Okay, So I'm going to keep working with the distance formula, but I did want to show you in relation to the Pythagorean theorem how they are alike. Okay, so let's take a look at this practice problem. I'm going to get you started, and then I'm going to see what you guys can do with it. So first we need to get the coordinate points for A and the coordinate points for B. So A is right here. It looks like we went -3 to 2. So I'm going to label that x1, y1. B is over here. We went over 4 down to -1. So that's x2, y2. So go ahead and substitute your numbers in, and then check back to see what the final answer is, if it matches yours or not. All right, let's see what you came up with. So first we're going to put in x2, which is 4, minus x3, which is -3. Then for y, we got y2, which is -1. And then we got y2, which is 2. So then we're going to go ahead and subtract what's in parentheses. So I'm going to subtract 4 minus -3, which gives me 7 squared, plus -1 minus 2 gives me -3 squared. Then we're going to go ahead and do 7 times 7, which is 49. We're going to do -3 times -3, which is 9. Go ahead, add them together. We get 49 plus 9, which is 58. Take your square root of 58, and you get 7.61 as the distance between the 2 points. And I'll go over the Pythagorean theorem version with this as well. But again, only works for right triangles. So you don't need to write this down, you can just kind of follow along. So I'm going to create my right triangle. Okay, so I'm going to find my length of A, 1, 2, 3, 4, 5, 6, 7. And then B, we should be 3, right? 1, 2, 3. And then we got A squared plus B squared equals C squared. So A is 7 squared, B is 3 squared, 7 squared is 49. 3 squared is 9. Add them together. 58. Take the square root of 58, 7.1. So the distance for C is 7.61. Okay, so they do equal each other.